Good morning, students. In last class, we are discussing about the applications of Planck's quantum theory. So, in that, the Planck's quantum theory perfectly explained two concepts. One is black body radiation. So, which one you called as black body? So that is a perfect absorber and emitter of radiation. So the scientists are created black body in what way? They are taken a halo sphere. They are taken a halo sphere and inside it is coated with so platinum black. So inside that is coated with platinum black. So now it is acting as similar to black body. So when we are sending radiation, means nothing but light. So that will be absorbed and emitted. So it is continuously absorbed, emitted and moving in all the directions. And it is acting as a perfect black body. In this black body, they are sending different wavelength of the light. And they are heating this bar, that halo sphere also. Then what they are identified means, so they are taken one graph. So intensity of light, they are taken on y-axis. Upon x-axis, they are taken wavelength. Suppose if the light wavelength is increases, so light wavelength is increases means their intensity is gradually increases and reaches maximum. And after that it is decreases. So that is max. So this is observed at T1 degree Celsius. Suppose if we are heating this part, so temperature is converted T1 to T2. Then what the scientists are identified that the curve is coming like this. So that means the maximum intensity is moving towards what? Lower lambda side. So here highest lambda, here lower lambda. So just when we are sending one wavelength, next time the wavelength of the light is gradually increases, then intensity also increases maximum and reaches down. Next, suppose the temperature is increases from T1 to T2 degree Celsius. So then what happens? The maximum intensity is moving towards lower lambda side. So lower lambda means already we know E equal to h nu, that equal to hc by lambda. What is the relation E and lambda? That is inversely proportion. So if you are heating means it is moving towards lower lambda. Lower lambda means highest energy. Next, highest lambda means lower energy. So generally in how we can explain means, suppose we are taken iron rod or iron material, we are heated. So we are heated up to T1 degree Celsius. T1 degree Celsius means it is looking like a red color. And further it is heated at highest temperature. So T2 degree Celsius, it is looking like blue color. See, that means at T1 degree Celsius, red means energy is low. So wavelength is high. So similar to this T1 degree Celsius, higher lambda. Blue color means its energy is highest, lambda is lowest. Suppose we are increasing the temperature, what happens? The energy is increases, otherwise the lambda value is decreases. So this is direct experimental. The same thing it is observed in a black body also. Next, one more point. This is explained through Planck's quantum theory. How? So red means the wavelength is very high. So blue color means wavelength is small. So the wave theory does not explain how this big wave becomes as a small wavelength. So wave, it is not splitted. So wave theory is failed to explain. But quantum theory means what? It has less energy. So less energy packets are there. If you are heated, so then what? Packets are combining. Packets are combining means what? You will get a high energy packet. So that's why Planck's quantum theory perfectly explained about how the red color becomes as blue color. So red color has a higher wavelength, blue color has a lower wavelength. So big wave, how it is converted to lower wave, we can't explain. But energy packet, so red has low amount of energy, blue has high amount of energy. So these two are mingled, you will get high energy. So this is experimental data that is explained theoretically. So then this theory is perfect. So this is the black body radiation. Here the important points are these two curves only. One is A. What is that? If lambda of the radiation is increases, intensity increases maximum and further decreases. That is one point. Next, if temperature is increases, then the maximum intensity is moving towards lower lambda side, otherwise the high energy side. These 2 points are important in the black body. In entrance also, which of the following is correct, which of the following is wrong. So they will ask. Next, the second application is a photoelectric effect. The second application so this is explained by Einstein through Planck's quantum theory. See, the name itself, photo. Photo means what? Light. Electric. So means electrons coming outside. So that is in the presence of light, electrons are coming outside with kinetic energy. That is called as a photoelectric effect. So if you take metal, if we have taken a metal that contains so many free electrons are there. So metal contains so many free electrons, because of this only metallic bond is happened, so it is available solid, that is the general point. Suppose when light is falling on this, so suppose some light, I am taking H nu. So if light is falling, so it has some amount of energy, it is touches to this, then what happened? In the metal, free electron is first absorbing this energy and it is moving from inner level to surface area. So that means some amount of energy is utilized. That is called as H nu naught. This is called as threshold energy. After that, anything extra amount that is taken by the electron and it is coming outside with the kinetic energy. See here the electron, which metal is readily loses their electron in the presence of sunlight means the metal which has the lowest IP value, ionization potential. Which metal has the least ionization potential means that is alkali metals. So Already, what are alkali metals? Our shortcut is lithophore. Lithium, sodium, potassium, rubidium, cesium, francium. So francium is a radioactive element, so we are not discussing that much. So these. Next, which one is more reduction potential? So it has a high reduction potential, means a high negative value. So that is readily loses electrons. So it has the highest, lithium has the highest reduction potential. This is the abnormal behavior of your first group elements also, one of the point. See, the same thing, concept, when light is falling, so it is coming here to here, means upon the surface, after that it is moving with kinetic energy. This is only you can write in the mathematical formula, means the light falling is h nu. Then what happened? The electron utilizing h nu naught amount of energy and it is taking kinetic energy. So this is falling energy. Next, this is the threshold energy. So these applications you can take in a different. So kinetic energy you can write in what way? So h nu minus h nu naught equal to kinetic energy. So h is common. Nu minus nu naught equal to kinetic energy. Nu minus nu naught equal to kinetic energy by h. So like that. Otherwise, suppose kinetic energy equal to what? Half mv square. So according to, they will provide these values and they will ask the velocity of the electron also. Otherwise, so everything. Next, if you take velocity means what? H into nu minus nu naught. 2 is coming here by m under root h equal to v. So that frequency, incident light frequency, threshold light frequency they will mention, they will ask velocity. So you can apply that one. Next, kinetic energy also is charge into potential. In the form of a potential, so one formula, this is kinetic energy. So this also it is applicable. So h nu minus h nu naught equal to E into potential voltage we can create. So that is also one formula. Next, nu equal to what? C by lambda. H nu equal to, you can write hc by lambda minus hc by lambda naught equal to kinetic energy. You extend with half mv square or you extend with charge into potential. So here who is common? Hc. Hc is common means 1 by lambda minus 1 by lambda naught equal to kinetic energy. So in the problem what they are asking, what the values are there provided, according to that you can move. So in the problems means the link up formulas. If you are perfect means whatever the problem you can do in that. Next, another two important points are here. Suppose I am increasing h nu. H nu is nothing but energy. Already Planck's quantum theory what? E equal to h nu. So if we are increasing energy means what? Nu is increases. So nu is increases means h nu naught. From inside electron coming out on the surface, it is a fixed amount. Remaining is what? Kinetic energy is only increases. Suppose here I am taken 10 units h nu. Here 2 units are utilized from inside electron coming on the surface of matter. Remaining is what? Here 8. If I am increasing 20 h nu, then what happened? This is 2 only. This is fixed. Remaining is what? 18 is here. So that means if 10 you are taken, 8 means 20 you are taken means 16. But actually more than 16 is coming. So that means so energy increases, nu is increases. Next who is increases? Kinetic energy. So that means H nu. Nu means frequency. Frequency of light increases. Then kinetic energy of the electron is increases. One important point. Next, second one. Intensity. Intensity increases. Intensity of light. So we are increasing intensity of light. What is the meaning of intensity of light? One light is falling, one electron coming outside. Suppose I send 10 lights. 10 light rays are falling means 10 electrons are coming outside. So that means what? Number of ejecting electrons are increases. So that means current is increases. Intensity of light is increases means current of electrons is increases. So otherwise simply current is increases. So these two are the important points. So important relation. Next, this is also how it is 10 units of energy we are sending. So it is splitted into two types of energy. So that means suppose you are taking a small wave. So highest energy means we are sending a small wave. Then what happened? Some energy utilized. Outcoming is what? In big manner. So how small wave become as a big wave? Otherwise it is utilized. Next, lowest energy means highest lambda is utilized. But here high amount of energy. So packet. Now this is splitted. So in what way? 2 energy packet and 8 energy packet. So energy is present in the form of packet means you can split. So previous what happened? The packets are combined. Now packets are split. So these two are perfectly explained according to Planck's quantum theory only. Okay, these two are the important points. Next, after this we are going to discuss spectra. So what is the meaning of spectra? So it is a combination of light energy. So in that important, suppose atoms are giving you some type of spectra, molecules are giving you. Next, it is classified into many types. Continuous spectra, discontinuous spectra, like that. So main, the spectra means the systematic arrangement of different lights. So in that first, electromagnetic spectra. So electromagnetic spectra is in what way? See, whatever we are seeing, visible region, visible light is a very small area. So after visible, what is the visible region? That is the VIBGR. So VIBGR colors. So it is violet up to red, indigo, blue, green, yellow, orange, red. See, after this region, see, violet before, this is UV light will be there. Next, gamma rays. Next, cosmic rays. See, it has energy is very high, lambda is very low. Next, after that IR, this is red after infrared. red after infrared, violet before ultraviolet. So here also near IR, middle IR, far IR, like that some range of lambda value or energy will be there. Next, after this microwave. Microwaves are there. Next, after macrowave. Macrowaves means the radio TV. So AM, FM. So like that further classification will be there. So these all are arranged in systematically according to their energy. Otherwise, see lambda value. So frequency is nothing but energy only. High frequency, high energy, lower lambda. So these have lowest energy. Lowest energy means lowest frequency, highest lambda. So the same formula you can apply in different form. You can explain energy form or frequency form, lambda value or wave number also, whatever it means. So wave number means what? 1 by lambda. So according to that, these values we can explain all those things. So this is electromagnetic spectrum. Next, already Rutherford concept we are discussed. So what is that? Line spectrum. Line spectra and band spectra. So Rutherford failure is what? Atoms are giving band spectrum, he told. But actually experimentally they are showing line spectrum. So means line is nothing but single color, monochromatic light. See, suppose we are taken VGR. So VGR means every single color. Every single color is a line. So this is what? Combination of different, all colors. This is called as a band. So individual single colors we can take as a single line spectrum. Now suppose a combination of so many colors or different wavelengths, that is called as a band spectrum. And important, line spectra is given by atoms. So this is important for us. Next, band spectrum is given molecules. Band spectrum. So simply you remember in what way? Atom combining with atom, you are getting molecule. So atom giving a light spectrum. So line spectra combining with another line spectrum. So combination of so many lines, you will get band spectra. So it is nothing but line means you can feel as a thread. So many threads are combining, you will get a cloth. So like that. So line combining with line, you will get a band spectra. Next, some other spectra. So continuous spectra and discontinuous. Continuous spectra and discontinuous. See, if all the different frequency of lights, they are continuously observed. So suppose you take VGR. So violet has highest energy, lowest lambda. Next, red has lowest energy, highest lambda. So here what? Every different colors or spectrums are continuously one after one, continuously coming. So this is called as a continuous spectra. Suppose in discontinuous spectra means between the spectral lines some black space will come. Suppose you take sodium. So sodium lamp. We are heated sodium. then it gives 2 lambdas, lambda 1, lambda 2 of yellow colors. When we are heating the sodium lamp means 2 lights are coming. That to be 2 lights are yellow range only, but different. Suppose if you see the spectra, here lambda 1 of yellow 1. Next here black space. Here complete. In this range you are getting a band of black. Black means there is no color coming outside. So here this is a lambda 2 or yellow 2. So one color after another color with black shade. So that's why that is a continuous and a discontinuous. Next, fourth, emission spectra. So emission spectra means we are heated. Suppose already we are discussed. You take iron rod and we are heated. Then what happened? The red color is coming outside. Suppose it is focused on black screen. So black screen. Black means what? Perfect observer and perfect emitter. So this black screen is looking like a complete red color. So this is what emission spectra means. We are heating iron. The material releases some light. Means it is emitted light. So the important one is color spots. Color spots observed on black screen. This point is important for emission spectra. Next, fifth, absorption spectra. So another one, absorption spectra we are seeing. So one object you take. In that object we are focusing Wuxia light. So this material capacity, it absorbs blue and green. It absorbs some light, some energy or some frequency of light is absorbed. Remaining it is emitted. Suppose it is coming outside. Emitted light we are taken on the white screen. So what happened? Violet is observed, indigo is observed. Here, blue area, one black spot is coming. Green area, black spot is coming. So yellow is observed, orange is observed, red color is also observed. So that means what? This material absorbs blue and green. So that area of the light is coming as black spots. So the important is in absorption spectrum, black spots are observed on white screen. Next, in emission spectrum, the important is color spots are observed on black screen. Next, very important other than the spectrums, that is a hydrogen spectrum. So in the next class, we will discuss about hydrogen spectrum, and now whatever we are discussing, that problems also tomorrow we will discuss.